Hello everyone, today we are going to discuss about Unit 2 antenna arrays. This is the syllabus for antenna arrays. Under this antenna point sources, array of point sources, 2 element array, n element array, broadside array, end fire array, concept of fixed arrays, pattern multiplication, tapering of binomial array, and Chebyshев arrays. And generally, if you are going to discuss about antenna array, something, but antenna array is considered as several antennas of similar type of are arranged in a system to radiate more in a desired direction with a high gain. And this can be achieved by combining individual antennas radiations in a desired direction by cancelling the radiation and undesired radiation, so which is nothing but we are going to connect the similar type of antennas in a system. So the antenna characteristics are similar, and either we can say about the characteristics and polarization and impedance value and length of the antenna, whatever may be it, we are going to consider about the similar type of antennas. So this kind of systems are called as antenna arrays. And if you are going to consider about the antenna array system of similar antennas oriented in a similar to get a greater directive in a desired direction. So in a particular direction you are going to have a desired direction. I have more directivity in a desired direction, and antenna array is said to be linear if the elements of the antenna are equally spaced along the straight line. So which is nothing but if you are going to place the antenna in a equal direction, equal distance. So the separation distance between the antennas will be same, means that it is called as a linear antenna, a linear array. And if the linear array is considered as a uniform linear array, when you are going to excite the antennas having the same signal, the signal having same current and equal magnitude and equal phase or progressive phase. And generally we have four kind of antennas: one is broadside array, end fire array, collinear array, and parasitic array. And the basic form of antenna is nothing but antenna array is nothing but if we are going to analyze the antenna arrays, we are going to consider about the 2 point sources. This is the basic structure. And if we are going to analyze the antenna array, means initially the analysis will be takes place for 2 point sources. Later this can be extended for several antennas. Antenna array of 2 point sources, and the point source is nothing but an isotopic radiator occupying a zero volume. It should be considered as a zero volume antenna, and number of similar point sources arranged in array to form the array. And the simplest form is nothing but we are going to have a 2 point sources, and we can analyze the antenna array in case of two methods. One is the 2 point sources of equal magnitude and same phase. Second one is the 2 point sources with the currents of equal magnitude and opposite phase. And third method is nothing but the 2 point sources with the currents of unequal magnitudes and any phase. And this is the first one, is the first structure, case 1. 2 point sources with the currents of equal magnitude and equal phase. And here A1 and A2. A1 is the point source 1, A2 is the point source 2, and separation distance between the 2 point sources will be D. And at point P we are going to measure the resultant radiation pattern, and the separation distance, the distance between point source P and A1 is considered as R1, and the distance between point source P and A2 will be R2. And when we are going to discuss about these things, after derivation we are going to have a maxima direction, minima direction, Hopper point direction, and the resultant radiation pattern looks like this. So and the maximum radiation takes place in a vertical direction 90 and 270, and minimum direction will be takes place in a 0 degree and 180 degree, and Hopper point will be in a direction of 60 120. Thank you.